Okay, let's try an unconventional math problem here. Find the last digit of an extremely large power, 777 to the 777th power. Now, there's no way we could actually multiply all that out and just see what the last digit is, so we're going to have to come up with some other way to figure it out. Here's what we do. The last digit of this number is going to be based on the last digit of this, the 7. Okay, so if we think about the last digit, every time we multiply sevens together, the last digit of 7 to the first, 7 to the first is 7. What about 7 squared? Well, since 7 times 7 is 49, the last digit of 7 squared is 9. Okay, and 7 to the third, well, since 9 times 7 is 63, the last digit of 7 to the third, it will be a 3. Now, the answer to this is not 63. It's just the last digit of it is a 3. Okay, go again, 7 to the fourth. Since 3 times 7 is 21, that means that the last digit of 7 to the fourth is going to be a 1. And then another one, 7 to the fifth. Since 1 times 7 is 7, the last digit of 7 to the fifth is going to be 7. And now you see, once that happens, you see how the cycle is going to repeat itself. The next one will be 9, and then 3, and then 1, and then 7, and then 9, and then 3, and then 1, and then 7. It's going to keep going over and over again. So really, there are only 4 options of what the last digit of this giant power could be. Right, here's how we're going to figure it out. Since there are 4 options, we're going to take this exponent, 777. We're going to divide it by 4 and see what the remainder is, and that's going to tell us which of these 4 options it lands on, and we'll know what the last digit of the number is. So 4 going into 777. Without calculators, here's long division. 4 goes into 7 once. Gives me a 4. Subtract, we get 3, and bring down the next 7. 4 goes into 37. 9 times, that's 36. Subtract, and we get 1. Bring down the next 7. 4 goes into 17 4 times. That is 16. And subtract, we get 1, and we're done. So the remainder for this is 1. 194, remainder 1. That means that the last digit of this giant power is going to be a 7. Here's remainder 1. If we had a remainder 2, it would have been 9. If we had a remainder of 3, it would have been 3. And now we would never get a remainder of 4 because we're dividing by 4. So instead, it would have said if there was a remainder of 0, then it would have been the last option, 1. For us, we got a remainder 1, so the last digit of this giant power is 7. All right, let's try another one here. Find the last digit of 934 to the 439. Feel free to pause if you want to try it yourself first. Otherwise, you can just keep watching. All right, so the last digit will be based on this 4 right here. Let's just run through the powers of 4 and see the last digits. 4 to the first is 4. 4 squared is 16, so the last digit is a 6. 4 to the third, if you don't know what it is, all you care about is the last digit. So if I take 6 and multiply it by another 4, that's 24, so the last digit of this would be a 4. Now, do you see that as soon as I got that 4 again, now the cycle is going to repeat? 4 and then 6, and then 4 and then 6, over and over again. So for this problem, there are actually only 2 options of what it could be. So we're going to take our exponent here, and we're going to divide it by 2 for those 2 options. 439 divided by 2. 2 goes into 4 twice, that is 4, so subtract, we get 0, and bring down the 3. 2 goes into 3 once, that's 2. Subtract, we get 1, bring down the 9. 2 goes into 19 9 times, that is 18. Subtract, we get 1, and there's nothing else to bring down, so 1 is our remainder. So our options here, we were only going to get remainder 1 or remainder of 0. When you divide by 2, you're not going to get a 2, you get a remainder of 0. We got a remainder of 1, so the last digit for this giant power would be 4. All right, I have one more. Try this one on your own. Pause the video. And here is the solution. 333 to the 336th power. It'll be based on the last digit 3. 3 to the first is 3. 3 squared, the last digit is 9. 3 to the third, if you don't know what it is, just take the 9, multiply it by another 3, you get 27, so the last digit is 7. 3 to the fourth, multiply by another 3, you would get 21, so the last digit is 1. 3 to the fifth, if I multiply by another 3, the last digit would be a 3. And see, that's when the cycle repeats itself. So for this problem, we have 4 options again, 3971, 3971, over and over again. So take this exponent and divide it by 4. See what our remainder is. Let's see here. 4 goes into 33 8 times. That's 32. Subtract, we get 1. Bring down the 6, I get 16. 4 goes into 16 4 times. That is 16. Subtract those, we have 0. Nothing else to bring down, so the remainder is 0. And here's how this works. This would have been remainder 1, remainder 2, remainder 3, and then you're not going to get a remainder 4 if you're dividing by 4. So this one is remainder of 0. The last digit of this power is 1.